Hi, Assalamualaikum and a very good evening. My name is Nur Shahira Yusra binti Mat Samsuddin and I'm from 4 Bank S3. Today I'm going to present about my final year project which titled Enhancing Security Monitoring by Utilizing Hybrid Location and Positioning Technique. This is my project abstract. As for my problem statement, advances in wireless communication, mobile technologies and global positioning technologies have renewed interest in location-based services among mobile users. Precision of location data helps for accurate query processing of location-based services. However, this may lead to severe security violations and several potential privacy threats as intruders and hackers, which have the capability to obtain users' information and use it for malicious purpose. So, the purpose of hybrid location and positioning technique in this project will assist users to maintain the privacy and security level by determining the user's common path and actual location. This project comes with three objectives, which is to develop a hybrid algorithm based on the LNP technique to further assist the security and safety users, to evaluate the purpose algorithm performance for security applications, and also to develop a hybrid LNP system by using MATLAB. This is the scope of work that I use, which is LNP technique, coding and simulation, and also determination. The project significant for this is highly efficient and accurate system where we combine two LMP technique, which is AOA and TDOA, to improve the accuracy in estimating position of a mobile station, and also we promote the level of security management and monitoring. As this is my background study, I did some research on a numbers of journals and also research to improve my knowledge regarding my project. This is my methodology, which is divided into three parts, which is literature review, development and simulation, and lastly, testing and improvised system. This is my system, which is a hybrid system combining of AOA and TDOA. AOA is basically angle of arrival, and TDOA is time difference of arrival. So basically, the system is to determine the exact real-time tracing location of users and to develop the hybrid LMP system for a better accuracy performance in location and positioning system. AOA, Angle of Arrival. As you can see, the above here shows the principle of angle of arrival, as the formula here is used to compute the coordinates of the target node, which is the T here, which referring to the mobile station. And as you can see, the B here referring to the base station. As down below here shows the method of AOA itself, where you can see N1 and N2, which is referring to base station 1 and also base station 2 to get much more accurate value and also the coordinates of mobile station. This is the simulation that have been done by using MATLAB. As you can see, there are two graphs shown, which first is the average for RSME of AOA algorithm. And the other one is the comparison of different standard deviation and distance of AOA algorithm. In order to get the D1, D2, and D3, we may also use this formula. Moving on to TDOA, which is time formula. Moving on to TDOA, which is time difference of arrival, we can use, this is the figure that is used, which is the TDOA technique implement the hyperbolic mathematical principle. This is the formula that been used to calculate the TDOA between the reference NI node and also another reference node N1. As you can see, D is equal to CT, which is D is the distance between two nodes and C is the speed of light. T is the time required for the signal to propagate from one node to another node. This is the simulation that have been done for TDOA method. So this is referring to the where n is equal to 10. We've done three simulation, which is n equal to 10 and also 100 and possibly to 1000. As you can see on the left side, is actually the user location that been estimated by using the TDOA algorithm. And the right side is actually the root mean square error for TDOA. This is for the n equal to 10, n equal to 100, and then this is n equal to 1000. From the graph, you can see that n equal to 10, estimation mobile users scattered at the surrounded of the actual user and did not specify on one noticeable location. And then when the number of n is increased to 100, it can see that the estimated mobile users scatter around the actual location of user, with most of them are slightly gathered around the center location. Next, when the n is increased highly to 1000, it becomes obvious that the estimated mobile user location is saturated around the actual user location. So, having higher accuracy compared to lower n value, the aspect of accuracy will be explained more based on the graph root mean square error, as shown on the right side. The n equal to 10 resulting RMSE up to 25, where n equal to 1000 resulting RMSE which only reached 6M. So smaller error in other words means that it have higher accuracy. It's because if the error distance between estimated and actual user is 25 m, there are many possibilities that not only one user is around 25 meter. So it is difficult to determine the actual user. Whereas if the error is only around 6 meter, it is possible to determine the actual user location due to the small difference of error in the distance. As for my hybrid system, I have done with a very long formula, which I don't include here. And this is basically the system, as you can see. And this is way or method to create the algorithm, which is based on the figure here. And I have some problems with the coding currently, and I'm currently still improvising the coding, which amount of error occur. So I will be presenting the results for my hybrid in with my panel. Thank The references that I've been used is included here and much more in my report soon. That's all from me. Thank you.